Alright, so we're looking at here, this is a diverging lens. I'm going to look how to draw the ray tracing for a diverging lens. So the same rules kind of apply. There's some subtle differences. So rule number one, what was rule number one? Draw a parallel line. That's the same. All the rules are kind of the same. You could summarize them as parallel focal, focal parallel, center center. Draw a parallel line. So let's do that. So from the object to the lens, and again we're going to go to the center of the lens here. Okay, and then what we're going to do is we're going to refract it. Now go back to think about that picture that we just drew. How am I going to refract this? Am I going to refract it down or up? Up. So you're going to refract it away, up, and away from the focal, which is on the same side. So what you're going to do is you're going to take your ruler, you're going to aim it with the focal point back here, and then you're just going to send it up, 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 like that. Okay, and that should be your beam 1. One of the things about these lenses is to remember is you never ever draw a line through the focal point. Never draw it through the focal point. It's always going to be aimed. Always going to be aimed. And that brings us to line 2, and this is where most people make the mistake, is line 2. So what you're going to do is you're going to draw a line, you're going to aim your line with the focal on the opposite side. And this is the beam that people always make a mistake. They go like this. That's the other kind of lens. For this one, what you're going to do is you're going to aim it with the focal way over here on the opposite side. Okay, aim it over here on the opposite side, but you never actually make it. You're going to stop at the lens, or the center of the lens. Okay, and how's it going to refract? Parallel. You're going to refract that guy parallel. Beam 2. Here we go. Alright, now beam 3 is the same. So no differences for beam 3. What's beam 3? Straight through the center. So no changes. Your line's just going to go all the way through the center, just like it did with the last one. So that's the easiest one of them all. So take your ruler, aim it with the center of your lens like this. Just keep it going all the way through. Okay, there's beam 3. Alright, there we go. 1, 2, 3. What do you notice about these 3 beams? They are diverging. Yeah, they're spreading out. So just like we've always done, you imagine, okay, what if I was looking at this with my eye? Even though if I put a screen right here, nothing's going to show up because there's no intersection. But if I were to look at it, it appears like light's coming in a straight line from somewhere back here. So just like we always do, when the beams are diverging, you're going to project back each of the beams and locate the image. So beam 1, remember, was aimed with the focal, so just line it up with the focal. I'm going to use dotted lines signifying that it's being projected back. Beam number 2 was the parallel beam. Okay, we're going to project that one back. Beam number 3, honestly, you don't have to do anything with beam 3 because it's already been drawn. I'll just do it just conceptually. You understand what you're doing is drawing back, projecting back this one. Okay, and there you go. There's your image. So the point, if you did it correctly, you should have a nice 3-way intersection right there. Let's draw on the rest of our image. Looks like that, like that. Draw it down. Okay, what do you notice? What are some conceptual characteristics of this image? Okay, it's upright, smaller, virtual. Okay, good. So remember, there's nothing actually there. You just think there is because of how you see things. Okay? Alright, let's go ahead and measure. See what we get. See how good our drawings are. Getting about 1, 2, 3. Alright, is that what you guys got? DI of 3. Something like that. 3.1, 3.2, something. Okay, let's measure the height. 1.3. Something like that. Should I make either or both or none of these negative? DI should be negative. Remember, for lenses, when we're on the same side, we want to make sure that our DI is negative. Okay, let's see how good my drawings are. Let's do the math on this. Equations are the same. One subtle difference. What's the subtle difference? Negative focals. You have to use a negative focal. If you do a positive focal, you're basically doing it for the converging lens. You're doing the math for the converging lens. So just remember, when you do diverging lenses or diverging mirrors, you use negative focal lengths. So hopefully my DI is close to 3. What's the perfect number? 2.92. Confirmed? Okay, so that's pretty close. Anyone actually measure 2.9? Bunch of you. Alright. H. HI over HO. What was our HO? 3 this time? What's HI? Okay, 1.2, 1.3, 1.25-ish. And it's positive, right? What's the meaning of positive? Upright. So that means up. And then what was the meaning of a negative DI? Same side. So remember, for lenses, same side for negatives, and positive would be on the opposite side. And lastly, let's get M. HI over HO. Positive 1.25 divided by 3 gives us a positive magnification. That means upright. And what's the actual number? And what's the meaning of 0.42? Okay, 42% smaller, exactly. Okay, any questions?